Hello, and welcome to another Algebra 2 lesson. This is lesson 6.7. Our objective is to classify data sets and use regression to write exponential and logarithmic functions. So before we get into exponential and logarithmic regression, let's practice linear regression. So here's a couple of warm-ups. Use the linear regression feature on a graphing calculator to determine the line of best fit for the data set. State the correlation coefficient of each. So here's our first table. If you have a graphing calculator, you're doing stat edit, stat calc, stat edit, put in your numbers, stat calc, tell it which type to calculate. We're going to use Desmos.com, so we're going to add a table. We're going to enter our data and then tell it that we want it to approximate the equation for us by putting in y1 is approximately equal to mx1 plus b. So write down your x's, write down your y's, enter these on Desmos. So you will click add a table, then you enter your numbers. Below that, you put in y1 is approximately equal to, you have a button above your tab bar that'll give you the little squiggle, or you can open the keyboard and click on the ABC and get the approximately equal to button right here. So y1 is approximately equal to mx1 plus b, mx1 plus b. When you do that, it gives you all of the information you need to be able to write your equation. Using this information, we'll write our equation. Y equals m is 1.8. So mx plus b, and b is negative 3.33. So negative, we'll round it to negative 3.3. Then it also said to state the correlation coefficient, that's the R. R is 0.99. Remember, we want R to be close to 1 or close to negative 1. When it's a positive R, it's a positive correlation. If it's a negative R, it's a negative correlation. So here's our answer for number 1. Do it again for number 2. I don't want you to use 2009, 2010, use 9, 10, 11, 12, 13, 14, and these numbers. Put those into Desmos and see what you get. So add a table. We want our numbers from our table over here, 122, okay, we've got our numbers. Now type in your equation, your y equals mx plus b, but it's y1 is approximately equal to mx plus b, mx1 plus b. And it will give us the approximations we need. So write down your m, write down your b. M is, we're going to round to 10th place. And it also asked for R. So the equation is y equals negative 1.6 x plus 139.5. The correlation coefficient was not as strong. It was a negative correlation. So as one thing increased, the other one decreased. Negative 0.8982. So that's not as close to negative 1 as we'd like it to be. So it's not exactly linear. There's a correlation, but it's not a very strong correlation. But that's a review of how to do regression for linear regression. And then today we're going to have to take that and that experience of doing that, but instead of putting in a linear equation, we'll put in an exponential or log equation when we get to those problems. Let's first talk about what makes it exponential. Classifying data. You've analyzed finite differences of data with equally spaced inputs to determine what type of polynomial function can be used to model the data. For exponential data with equally spaced inputs, the outputs are multiplied by a constant factor. So consecutive outputs form a constant ratio. So in other words, as long as your x's are increasing by the same amount, analyze your y's. If I go from here to here, can we multiply by the same number each time? What do we multiply by? Yep, times 2. We're multiplying each time. Does that work here also? 0.5 times 2 would be 1.0. Yep. So that is an exponential function. Because we multiply to get to the next number. It has a constant factor of 2. All right, this next one, can we multiply to get to the next number? Nope, not really. How about adding? Well, we're not adding the same thing every time. So let's analyze the finite differences. What could we add to get to this one? We could add a negative 2. Then we could add 2, add 6, 10. What about this one? 18 to 32. 14. 32 to 50 is 18. Okay. If these were all the same, that would be a linear. But it's not linear because those were not the same. So we're going to put not linear. These would all be the same if it was linear. So let's look at the second differences. If these second differences are the same, then it's quadratic. That would be an x squared. So let's see if it's quadratic or not. From negative 2 to 2, we would add 4. 2 to 6, add 4. Add 4. Add 4. Look at that. Add 4. These are all the same. So it's a quadratic equation, which tells us it would have an x squared. So this one is quadratic. So if we wanted the equation and we were using Desmos to help us, the equation we would use would be y1 squiggle, y1 approximately equal to ax1 squared plus bx1 plus c, and then it would tell us what numbers to use for a, b, and c. Okay, but for now it just said determine the type. So exponential function and a quadratic function. Let's practice writing some exponential functions. Write an exponential function, y equals a times b to the x, whose graph passes through 1, 6, and 3, 54. So here's the steps we're going to use. We have to find what number a is and what number b is. What they've given us is 2 different points that are on the graph. So we can use these as an x and a y. We can use 1/6 to write an equation. We can use 354 to write an equation, putting those numbers in for x and y. So that's the first thing we're going to do, write two separate equations using the given points for x and y. Once we do that, we have a system of two equations that we can solve. So solve that system of two equations for a and b. Write the exponential function in the form y equals ab to the x power. That should be an exponent. Putting in the numbers found for a and b. All right, let's give it a try. So y equals a times b to the x. Okay, start with the 1 and the 6. Y is 6. When x is 1. And then the second equation, y is 54. When x is 3. Now that we have two equations, we can solve the system. So what we're going to do is solve equation 1 for a. B to the first power is just b. So to solve for a, we're going to move the b to the other side by dividing both sides by b. So a equals 6 divided by b. Now that we have that, we can put this in place of a in the other equation. Now we have an equation with just a b in it, no a's, so we can solve for b. So this b will cancel out one of these b's, making that b squared. So that 54 equals 6b squared. Solve for b. Do the squared by square root. B equals 3. Now that we have b equals 3, it would be plus or minus 3, but we want a and b to both be, we need b to be positive. So b is 3. And if b is 3, then a is 6 divided by b from over here. And 6 divided by 3 is 2. So b is 3, a is 2. Now you can write your equation. So we're on to step 3. Write the exponential function in the form y equals a times b to the x, putting in the numbers found for a and b. A times b to the x power, putting in our a and b numbers. So a is 2 times 3 to the x power. And that is our answer. The more we practice, the better we get. So this was example 2. Write your two equations using x and y. Solve one of the equations for a, especially if they have one where it's easier because this is b to the first power. So solve one of the equations for a, substitute that expression into the second equation, solve the second equation for b. Once you have numbers for b, go back and find a number for a, and then write your equation. Let's try it again. This time we have 212. And 324. So here's our two equations. Using those 2 points, solve for A in the first one, substitute it into the second one, solve for B. Once you have a number for B, go back and find A and write your equation. On your mark, get set, go. And there's our answer. Okay, I solved the first equation for A. I got 12 over B squared. Use that in the second equation. Simplify these. B cubed divided by B squared is just B. So 24 equals 12B. Divide both sides by 12, we get B equals 2. Once we have a number for B, put it in our expression for A. A equals 12 over B squared. 2 squared is 4. 12 divided by 4 is 3. A is 3, B is 2. Write your equation. All right, pause here and try the other two problems. Pause and give it a try. All right, there's number 4. Check your answer. Try number 5. And here's number 5. Hey, this one was definitely more work. Wrote your two equations, get A by itself in one of the equations, substitute it into the second one. I had 2 equals 16B cubed. Divide by 16, we get 2/16. Simplify, that becomes 1/8. So we have 1/8 equals B cubed. We had to do the cube root of both sides. The cube root of 1 over 8 is 1 over 2. As the cube root of 1 is 1, the cube root of 8 is 2. So B is 1/2. Once I had B as 1/2, went back up to our A equation, 16 over 1/2 squared. 1/2 times 1/2 is 1/4. Any number divided by a fraction is the same as that number times its reciprocal. So 16 times 4 is 64. A is 64. B is 1/2. I don't know if you noticed, but as the x's were getting bigger, the y's were getting smaller. So this one was a little different than ones we've had in the past. We have a 1/2, a number smaller than 1 that's being raised to a power. So our numbers are actually getting smaller. So there's another example for you. All right, pause here if you need more time to look at these. You have quite a few of these in your assignment. Sometimes they'll give you 2 points on the graph. Sometimes they'll just list the coordinates of the points like we did here. If they give you a graph and they label 2 points for you, you're still going to do the same process as you see here. Finding models. We're now going to use a graphing calculator. Example 5. A store sells trampolines. The table shows the numbers Y of trampolines sold during the X year that the store has been open. Use a graphing calculator, which includes Desmos, to find an exponential model for the data. Then use the model to predict the number of trampolines sold in the 8th year. So for an exponential model, we're going to use Y1 is approximately equal to A B to the X1. So we'll go to Desmos, add table, put in these numbers, and then this is the equation we'll type in box 2. All right, here we go. Okay, it's the numbers 1 through 7. Add table. Put in our other numbers. And then tell it what equation you want. So we didn't want a logarithm, so we're not in log mode. We're just a b to the x. Use these numbers. A is, we're going to use 2 decimal places. Did it say? We have 8.9726 and B is 1.40265. Our R squared number is really close to 1, so that's a good match. So we get our equation, y equals, let's go with 2 decimal places, 8.97 times 1.40 to the x power. So we found our model. Now use the model to predict the number of trampolines sold in the 8th year. So this is year 1 through 7. We want to know what should it be for 8. So using x is 8, we're going to use a calculator. To find this, or you can use Desmos as your calculator. This is what we need to find though. 8.97 times 1.40 to the 8th power. There's our number. So I put this in 132.38. And it's trampolines, so it would be about 132 trampolines. So at this pace, exponential growth, that would be the next number. 132 in 8 years, 132 trampolines. All right, that was using Desmos, putting in add a table, putting these in, and notice at the top of the table it had an x1, y1, and that's why when we type in the equation, we have to use an x1 and a y1 and an approximately equal to. If you put in an equal sign, it's not going to give you the numbers you need. And the R value should be close to 1 or -1 if it's a good match. So that's exponential models. What about logarithmic models? Okay, finding a logarithmic model. The atmospheric pressure decreases with increasing altitude. At sea level, the average air pressure is 1 atmosphere. The table shows the pressures P at selected altitudes H. Use a graphing calculator to find a logarithmic model of the form H equals A plus B ln of P that represents the data. Estimate the altitude when the pressure is 0.75. Oh, that was a lot to read. So it comes down to, for X and Y, we have P and H. We're just going to use X and Y on Desmos. So for this equation, we're going to have Y equals, and we'll actually do Y1 is approximately equal to A plus B times natural log of X. And we need a 1. Okay, so that's the equation we're going to put in with this table. So go to Desmos, add your table. Clear the old table first, then add your table. Type in your table, then type in Y1 is approximately equal to A plus B ln of X1. So that's your natural log. A is 0.86. B is negative 6.45. If we round to hundredths place, then we write our equation. Y equals 0.86 plus, negative, I could have written minus 6.45 times the natural log of X. So this is our equation. That is a minus 0.86 minus 6.45 times the natural log of X gives us the relationship between the air pressure and the altitude. So we've got the logarithmic model. Estimate the altitude when the pressure is 0.75. So we want to know when the pressure is 0.75. So that's the P, which in our case is the X. So we're going to put that in for the ln. Push buttons on our calculator and get an answer. So we get 2.72 if we round to hundredths place. We want to make sure that makes sense. So let's look at our table. If X is 0.75, that would be between these two numbers here, between 1 and 0.45, is 2.72 between 0 and 5? It is, so that seems to make sense in the context of our problem. And then what was altitude measured in? It was measured in kilometers, so I made sure I gave a label to my answer. Now, if you did this on a graphing calculator and not Desmos, on an actual like a TI-83 or 84, your numbers would look like this, but we would still have had the same final answer as we got from Desmos.com. Okay, so for the logarithmic model and exponential model, we just have to make sure we know our equations. For your regression, here's your exponential, your logarithmic. I also included the linear. Make sure, oh goodness, can't do an equal sign. You have to